Okay, so as you can see, we're going to do reflections. They're labeled with a lowercase r. This is just a bunch of examples. If you could get some graph paper out to go along with it, I'd love for this to be in your notes section. I will be looking for it in your notes section. Just write the date at the top, please. Either the date that you turn it in, whatever dates you like having at the top, because I just want it to be in order from when I check your notebook. So, I've already written down my x-axis and my y-axis. Forgive me for this, I'd gotten done writing and I didn't want to rewrite it all over. So, remember when I reflect across the x-axis, I'm reflecting across this piece, right? And the y-axis is this. The x tells me all the possible x values. The y value tells me all the possible y values. So, we're going to go ahead and do this y-axis reflection. When I reflect across the y-axis, it flips over. So I would be able to count how far away everything is. For example, right here, A is 1 away, so that would also be 1 away. Or I can use this rule down here, that if you can remember the rule, it's going to make everything easier because you don't have to count so much. So we're going to use the rule and then I'll plot the points for you. What we're going to do is x comma negative y yields negative x comma y, so I'm going to negate all of my x values and leave all my y values the same. Since it doesn't go up and down, my y values can't change, right? So we started with 1, 1. That would mean negative 1, comma 1. I've got 3, 7. I'm going to have negative 3, 7. Remember, x value changes. And I've got 4, negative 2. My x value changes. Negative 4. And my y value stays the same. Go ahead and plot those. Negative 1, 1. Negative 1, 1. Already done. We did that with the counting across, right? Negative 3, 7. 1, 2, 3, up 7. This is where it's actually kind of easier to use it. Up 7, 1, 2, 3, 4, 5, 6, 7. And finally, C was negative 4, negative 2. 1, 2, 3, 4, 1, 2. Because remember, my negative signs here just mean I'm going backwards or down. Now we're going to do across the x-axis. That means I'm flipping this way, right? My x values will stay the same, my y values have changed because the height has changed. So, right here, my x value stays the same, my y value negates. That's the rule that I have. So we're going to go ahead and do that rule. X value stays the same, 1. Y value negates, 1 becomes negative 1. X value stays the same, y value negates, 3, negative 7. X value stays the same, y value negates, that's going to be 4. And then when I negate a negative number, it becomes positive. It's like multiplying by a negative number. And we'll go ahead and plot those. We've got 1, negative 1, 1, negative 1. We have 3, comma, negative 7. And C is 4, positive 2. 1, 2, 3, 4, 1, 2. Sorry. So a lot of y'all have been asking me what happens when I have something like this. It is fine that my values flipped across the axis like that. They're obviously going to do that since this one was on this side of what I reflected across. And this one was on this side, right? And just make sure that the point that you reflect is on the opposite side of the point originally, right? And this crossing of my pre-image and my image is perfectly fine if the line of reflection goes through my pre-image. Okay, so we just did the y-axis, we just did the x-axis. Now we're going to do the y equals x line and the y equals negative x line. And these would be my lines of reflection. This purple one would be my y equals negative x. The green one is my y equals x. Remember, the way that I would find this line would be 1, 1, 2, 2, 3, 3, 4, 4. It is literally where y and x are the same thing or equal each other, right? So let's go ahead and do this y equals x. I think that the rule is a lot easier in this one because remember, this is the one where we did it without a rule. We had to count up and then we could count over and then we counted up or down. So if we use the rule, all we have to do is flip our x and y. So example, I'm going to go ahead and do B because in A, when I flip 1 and 1, I'm still going to have 1 and 1. So these two would flip back and forth, they'd be 1 and 1. Not the best example part for this one. However, when I have 3 and 7, what's going to happen is the 7 and the 3 switch places. So I have 7, 3, which may be more like alluding to what's happened in that first one. So my 3 and my 7 switch places. And finally, I have 4 and negative 2. They would also switch places. So I'd have 4, negative 2, 4. Alright, they switch places. I have negative 2, 4. And we plot those. As you can see, A is in the same place. If I have a point on the line of reflection, it remains the same. And then we've got 7, 3, 1, 2, 3, 4, 5, 6, 7, 3. And we've got C at negative 2, 4. 1, 2, 1, 2, 3, 4. 4 up here. I'm sorry, y'all. It is up here, positive 4. Okay. Well, make sure that you did not make this mistake that I made and count backwards both times. When I have a positive number, I have to go upwards. So, as you can see, once again, B reflects this way, but C reflects that way. They're on opposite sides of my line of reflection, so and my line of reflection goes through my figure. So I will have a point that flips sides. Right, 2 different points will be on 2 different sides. Okay, we're going to do y is equal to negative x. I've got that line right here already drawn. This is where we've got 1, negative 1, or negative 2, 2. One of them is going to be negative, one of them is going to be positive, but they're going to be the same number. And our rule here is going to be flip them and negate them. So flip them like I did with this one, and then change the sign. So 1 and 1, 1 and 1, they're both positive, they both become negative. 3 and 7, flip them. 7 and 3, negate them, so change their sign. I've got negative 7, negative 3. And finally, I've got 4, negative 2. I flip them, negative 2, 4, and change their signs. That gives me positive 2, because remember, negate means change the sign, which all I did was multiply by the negative sign, right? And now we can plot them. We have A is negative 1, negative 1, A prime. B is negative 7, negative 3. 2, 3, 4, 5, 6, 7, 1, 2, 3. Now I've got C at 2, negative 4. 1, 2, 3, 4. And those look like butterfly wings almost over it. So you can see over this line of reflection, this would flip onto that. Okay, I have redrawn my graph for the next one for the reflection across x equals a number and y equals a number. My last graph was just getting a little crowded. And I've written down this whole rule. You can always count how far it is, but this is going to be easier if you've got like a big number. Okay, so we're going to reflect across this line, right? X equals negative 2, or positive 2. Sorry. We're going to reflect across x equals 2, and that is opposite of this line, the x-axis, because the x-axis tells me all possible x's. I want one x every single time. Now, I'm going to take my original x or y, in this case x because I'm reflecting across an x. My original x in A was 1. I'm going to subtract my line of reflection, minus 2, and find that number. That number's negative 1. I'm going to take my line of reflection, still 2. I'm going to subtract the number I just found, so minus negative 1, positive minus a negative, the add, that's 3. So my new x value would be 3. My y value doesn't change because I don't go up or down. It stays at 1. So if I had just counted, I'd go over 1. So I'd go over 1 more. A would be right here. If we take our point we found, that was 3, 1, 3, 1. We're going to do B. B was originally 3, 7. So I'm going to take my original x value, because I'm still changing, I'm reflecting across an x number, not an x-axis, an x number. If I reflect across the x-axis, my y would change, right? But we're reflecting across x equals a number. So my x value is going to change. We're going to do 3, because that's my number, minus my line of reflection, equals 1. And then my line of reflection minus the number I just found, that is 1 again. So we're going to have 1, 7. 1 up 7. Once again, that was 1 away on this side, so I could have just counted over. This is a lot more useful if you got numbers that are like 9 or 10 and you don't want to have to keep count. You're afraid you're going to mess up. This is useful then, but easier to show like this. 4 is, C is 4, negative 2. Sorry guys. Okay, I take my x value, 4, minus my line of reflection, equals 2. I take this new number, I subtract my line of reflection, I get 0. My new x value is 0, my y value stays the same. My new x value is 0, I still have 2, negative 2. There's C prime, but you can see that reflects over there. Right. That's a pretty cool looking shape.